Question 5a asks us, to what extent can the discount, discount change, or what discount should we have in order to have a relevant cost of 0? So we know that we need to increase this analysis by 2.2 million, but to what extent can we do that by changing the discount? Now the question really is, where do we find this discount within our analysis? Not all of these numbers were calculated with the discount as a variable in the calculation. And so we need to go find where it is. And so we see for the first line item, we have the discount over there. We don't have anything in these 3 line items. Then when it comes to 7% growth, we see that the discount is hidden within this number. So we can calculate that number by taking the selling price, or the original selling price, times by 1 minus the discount, which is 0.2, and you'll get 16,000. We also see that in none of these line items do we find that 20% discount. So what that means is, if we change the variable that is the discount, only 2 line items will actually change in our analysis, and that is the 52,000 and the 52 million and the 12 million. Okay, so these numbers need to somehow be increased by 2.2 million in order to understand what discount we are going to need. So how do we do that? Okay, so we're going to change this analysis, these 2 line items, into a mathematical formula, and then we make the discount x. So instead of having the 20% there, we make it an unknown variable x, and we use all the information we have to solve x. So let's go down there. We see 52 million is equal to that. So we say, okay, so minus, because it's a minus in the analysis, minus 52 million plus 12 million plus the increase that we need, 2.2 million, is equal to, well, the workings that we have on this side. All these inputs over here equal that number, but now we've added this, we've added that, and we've added that. So on this side we'll also do that. Okay, so the 52 million is equal to minus the 20,000 selling price times the discount, which now is x, because we need to solve the new discount. That's going to result in an increase of 2.2 million, times the 13,000 units, plus, now we add this formula. We're just going to simplify it first because I don't want to write it all down. So this bracket here is equal to 910, and these variable costs are equal to 2747. Okay, so we rewrite that and we say plus 910 times, let's make it a bracket within a bracket, 20,000 rand times 1 minus x. Okay, so minus the variable cost. Okay, lots of brackets there to make sense of the progression of the maths. But that's basically what we need to do. And we see there's only one unknown within this whole formula, x, and so we just simplify it to get that x is equal to 19.19%. And that's what you'll see in your solution. But it's a thought process, knowing that this side needs to increase by 2.2 million, and on our left-hand side, we write down our workings. And so what you'll see in your solution is that these amounts added together gives us, let me just go to the solution, minus 39,939 and 770. Okay. And that is how you solve the first question.